because I want to give you enough time to work on those example problems. So the first thing I want to go over is the properties of exponents. So the first one up top there is the zero exponent. Okay, so any number raised to the 0 power is equal to 1, except for 0, which is not defined. So if I have any number a raised to the 0 power, that's always going to be equal to 1. Doesn't matter what number you plug in for a, anything to that 0 power is always 1. So my example here, if I have 4 raised to the 0 power, again, that's just going to equal 1. It does not equal 4. It does not equal 0. Okay, it equals 1. The next property we have here is the negative exponent property. So negative exponents indicate reciprocation, with the exponent of the reciprocal becoming positive. So reciprocation meaning you're switching either to the numerator or denominator. Okay, so you have this fraction piece here. So if I have any number a raised to the negative power, or negative n in this case, that will equal 1 over a to the n. Okay, so when you see this negative symbol in your exponent, you need to flip it to the denominator. Okay, or if it's already in the denominator and you have this negative exponent, it needs to flip to the numerator. That's how we got a raised to the n power. Okay, so that negative flips it either to the denominator or the numerator. So my first example here, if I have 3 to the negative 2, well, that negative will flip that whole thing to the denominator. So we'll have 1 over 3 squared. Okay, so that 2 still stays the same. That negative will go away once you flip it or reciprocate it. Okay, and I can simplify this one a little bit further. So I have 3 squared, which is just 9. Okay, so I can simplify that further to 1/9. My second example for this property is if I have 1 over 4 raised to the negative 3. Again, that negative means reciprocation, so I need to flip it to the numerator. Okay, so once I flip it to the numerator, the negative goes away. Okay, but you still have that 3 as your exponent. So now I have 4 raised to the power of 3. Okay, thank you. So 4 cubed is 64. Okay, questions on either of those two properties? All right, so the next property I have on here is product of like bases. So to multiply powers with the same base, add the exponents and keep that common base. Okay, so you do need a common base for you to do this. So here I have a raised to the m power and a raised to the n power. Those two are multiplied together. Both of those bases are a, so they're the same base. Okay, that's what it's talking about when it says common base. They have to have that same number, that larger number on the bottom. So when that happens, I can keep my same base and I can add the exponents. Okay, so I'll have a raised to the m plus n. Okay, so example, if I have 2 cubed times 2 squared, I'm going to keep my same base of 2, and I'm going to add my exponents together. So 3 plus 2. Okay, so I'll have 2 to the 5th power. Everybody know what 2 to the 5th power is? Hey. 2 to the 5th power is 32. Okay, questions on product of like bases? Okay, the next one is quotient of like bases. So again, you're going to have that common base. So to divide powers with the same base, subtract the exponents and keep the common base. So before we were multiplying with the same base, now we're dividing with the same base. So instead of adding, we'll subtract. So if I have a raised to the m power over a raised to the n power, that will be our common base of a raised to the m minus n power. Okay, so an example of this, if I have 3 to the 5th over 3 to the 3rd, I'm going to keep the same base of 3 and subtract my exponent. So I'll have 5 minus 3. Yes?
What happens if you have different bases? Do you still subtract the bases?
No. Okay, this will reduce to 3 squared. Okay, and that does simplify to just 9. Okay, our next one is a power to a power. Okay, so to raise a power to a power, keep the base and multiply the exponents. So this is where you'll see parentheses around your base that has an exponent with it, and it's raised to another exponent. Okay, so if I have a to the m, that quantity raised to the n power, you're going to multiply your exponents. So you'll keep that same base, multiply your exponents. So if I have 2 squared raised to the 3rd power, I have my base of 2, and I'm going to take 2 times 3. Okay, so I'll have 2 to the power of 6, which is 64. Okay, questions on quotient or power to a power? Yes, Heather.
So when you have a power to a power, you never do anything with the base?
If you have extra stuff with it, then yes, you do.
Like if it's like 8h to the 5th, and then do you have parentheses the 2nd, would you multiply? Like would
You would distribute that second power to all 3 of those different bases. Because those are 3 different bases.
Variables active.
Yes. Okay, so the next one I have here is product to a power. So to raise a product to a power, raise each factor to that power. Okay, so if I have a times b raised to the m power, that will be a to the m and b to the m. Okay, so you distribute that m to both of those different bases. Okay, so an example of this, if I have 2 times 3 raised to the 2nd power, yes, you could multiply 2 and 3 together first, but for this case, I'm going to distribute my power. So I'm going to take that power, distribute it to both of those bases, so to 2 and 3. So we'll have 2 to the power of 2 times 3 to the power of 2. Okay, so when you're distributing your exponent, so that square there has to be multiplication between those 2 terms. If it's addition or subtraction, you cannot distribute that power. Okay? Only if it is multiplication and division can you distribute the power. Okay, so I can simplify this a little bit further. 2 squared is 4. 3 squared is 9. Okay, and 4 times 9 is 36. Okay, questions on the front? All right, so on the back then, the seventh property here is quotient to a power, so it's very similar to the last one we just did. So to raise a quotient to a power, raise the numerator and the denominator to that power. Okay, so just like before, we can distribute that power on the outside of the parentheses to both terms, okay, since it is division. So if I have a over b, that quantity raised to the n power, that n can distribute into that a and to that b. Okay, so I'll have a to the n over b to the n. And again, this is only true if it's multiplication or division inside those parentheses, not addition or subtraction. So this example here, I have 2 over 3 raised to the second power. So I can distribute that 2 to both of those terms. Okay, so I'll have 2 squared over 3 squared. Okay, and I can simplify that. So I'll have 2 squared is 4 over 3 squared is 9. Okay, questions on quotient to a power? Yes, Hadley. You can't. All right, the next one here is rational exponents. Okay, so this is the one you might not have seen before. Shh. You may not have seen this one before. Can we please stop the conversations? I know they are too. But you were the entire time I was talking before, so. So the denominator of the rational exponent, shh, please stop. The denominator of the rational exponent becomes the index of the radical. Okay, so index meaning that term outside of your root. And the numerator becomes the exponent of the radicand. The radicand is the number inside your root. Okay, so if I have a raised to the power x over y, so you have a fraction as your exponent. That y value or denominator is what the root is. Okay? And that x still is the exponent of a. Okay, so looking at this example here, I have 2 raised to the power of 2/3. Okay, so the denominator of that fraction becomes your root. Okay, so this will be a cubed root. Okay, so that's where that little 3 goes on the outside. Okay, then I still have this 2 inside that root. And then the 2 in the numerator stays with that base 2 from before. Okay, just to make it look a little bit nicer, we'll have the cube root of 4, because I just took 2 and squared it. Okay, questions on that one? All right, before I go onto the last section, I do want to do a couple examples on the board. So you can use any of the white space around your paper on the front or back to do these example problems. But I do want you to do the example problems. So the first one I have here is 7c cubed 6 to, or h to the 6th times 9 z h to the 4th. Okay, so you have 3 different bases. Okay, in each of those, you have 3 different bases. So what you can do with this one, I'm going to go through this one together with you because I know I didn't do examples like this on the board. So since this is multiplication, and you do have these whole numbers here, you can multiply them together. Okay, so my first step is to take 7 times 9. What is 7 times 9? 63. All right, next I want to look for like bases in my variables. Well, I have 2 z's here, right? Those are common bases. Okay, I have a 3 as an exponent and a 1 as an exponent. Okay, if it doesn't have an exponent on it, it's 1. Okay, it's not 0, it's 1. So, since those are common bases, I can add those exponents together since this is multiplication. Okay, so I'll have z to the 4th. And then same thing with h here. You have that common base. Okay. You have the common base. And again, I can add the exponents. So you have h to the 10th. Okay, and that's how you would simplify that first example. Okay, questions on how I did this one? All right, your second example here is 9r to the 4th times 4r to the negative 2nd times 8r to the negative 6th. Simplify that expression.
If it's a negative, what does it do? It's not like so it's just negative, does it mean anything? Like does it like
Wait, Mr. Gill, then it will just be 4 plus 6 now.
See, idiot. You say she was dumb.
Mr. Gill, if you have the, but if it's 4 to the 4th over 4 to the 10th, is that just 4 to the 6th? I don't know, but like,
Looks like you.
All right, so for this example here, you should get 288 over r to the 4th. Is that what you got? So you should multiply all 3 of your terms together there. So 9 times 4 times 8, 288. Then I can add each of my exponents that have common base of r. So I have 4 plus negative 2 is 2. And then 2 plus negative 6 is negative 4. So what I got was 288 r to the negative 4th. But that negative, when you simplify, you can't have a negative in your final answer as an exponent. Okay? All of your exponents need to be positive. So that flips that to the denominator. Okay, questions on that one?
you subtract the bases. If you have a base of 25 on top and a base of 9, so you see 25 on top.
All right, one more example here. If I have 5w over 3w to the fourth, that quantity squared. Simplify. Yes.
Easy. 10w over 6.
No.
Why not?
Because that's a square.
What are you talking about now?
You're not multiplying the 10 by 2.
Oh, you're right. Square is 25 over 9. See, you got it.
And you don't, you have to put the number that's the negative exponent. Not only if it was a
Big five
quantity
W.
negative exponent.
Look, everything 5w. 3w over 6. Like you're gonna take all that air away.
Yeah. So, with this example, you do need to distribute your square to each of those terms. So it needs to go to the 5. It needs to go to the w. It needs to go to the 3. And it needs to go to w to the 4th. It needs to go to all of those terms. Okay, so I'll have 5 squared, 25. I'll have w squared over 3 squared is 9. And then w to the 4th squared, what would that be? You need to remember to multiply your exponents. Okay? So if it's an exponent raised to another exponent, you multiply them. Okay? You don't add them. The only time you add them is if you have common bases. Okay, from here I can simplify further. Okay, so I'll take, please stop talking. I have to keep 25 and 9. I can't simplify that fraction. Okay, so that's going to stay the same. But I can simplify these w's. So I have a similar base. It's in a fraction, so I can subtract my exponents. Okay, so I'll 2 minus 8 is negative 6. Now if I have w to the negative 6, what does that do? It flips it to the denominator. So we'll have 25 over 9 w to the 6. Okay, so you do need to apply more than one property of exponents to these simplification problems. Okay, question on that. All right, last thing that I want to go over in your notes here, okay, is FOIL. Shh, we're quiet now, please. So the product of two binomials is the sum of the products of the first terms, the outer terms, the inner terms, and the last terms. So FOIL, first, outer, inner, last. Okay, so we're going to find the product of these two binomials. So when you have that addition and subtraction between your numbers, you need to FOIL. Okay, that's what I was talking about before, where if they're multiplied together, you can distribute, but in this case, you have to FOIL. So we're going to take our first terms and multiply those together. So we have x times x is x squared. Our outer terms, okay, so x times 5 is 5x. Our inner terms is 3 times x. So this is supposed to be negative, I'm sorry. This is 3x. Yeah, I lost the negative there. It's minus 5x, sorry. I got distracted when Cassidy walked in. And then our last terms is 3 times negative 5. Okay, so that will be negative 15. Okay, so from here you want to combine like terms. Okay, so those, please, those middle two terms you're going to add together. Okay, so we'll have x squared, and then we have negative 5x plus 3x. So we have minus 2x minus 15. Okay, so that would be that final product there. Okay, second example I have here is 3y plus 2 times the quantity of 5y plus 4. Okay, so again, we're going to FOIL, so we need the first terms. So we have 3y times 5y is 15y squared. Our outer terms are next. So we have 3y times 4, which is 12y. Then our inner terms, which is 2 times 5y, so 10y. And then our last terms, so 2 times 4 is 8. And again, you want to combine like terms. So we'll have 15y squared plus 22y plus 8 as our final answer. Okay, so is this starting to kind of come back to you, your properties of exponents and how to FOIL? Okay, any questions before you start working through your assignment?